Hello everyone. This video is going to show you one of your homework problem. It's 1343. Okay, and 1343 is also a very easy one. But since someone asking the problem, so I just do the video for this. It says yeah, a mass M slide along a frictionless surface on horizontal surface at speed v0, and it strikes the spring, and the spring has force constant k. Okay, after the elastic encounter with the spring, the mass head back to its direction and when direction it came from. Okay, and this problem want to find how long the mass in contact with the spring, okay, in terms of k, m, and v0, and what's the maximum compression of the spring during the compression. Okay, I think maybe the problem is the A problem. Okay, B is very easy. Okay, the problem A is how long does the mass in contact with the springs. Okay, so here is, I think the situation is, okay, so let's see. Okay, let's assume, okay, this end strikes with this spring. So let's start from, make a line here. Okay, and after the M strike the spring again, it's compressed, right? So maybe I just assume it's moved to here. Okay, so it goes to this direction, and then after compression, it will store the energy, and then it's release energy. So and then it's go back. Okay, go back. And okay, it wants to calculate what's the time. Okay, what is the time? What is the time? Actually, if you look at it carefully, it's just the half period, the simple harmonic oscillation, right? The simple harmonic oscillation. Okay, if we start from here, here goes to compress and release, and then if it's simple harmonic motion, it will be go back to this position again, and then go back to this position again. So 1, 2, 3, 4. That's one cycle. Okay, that's the one cycle. That's a one cycle is t. Okay, and now if you want to, this problem just want to calculate the mass in contact with the spring. I think that this problem is trying to say is, okay, when the M strike the spring, it's compressed and then it's released, and after this and after he returned to its position, the block just leave the spring. Okay, after this block return to this position, and then the block just release the spring. Okay, that doesn't contact anymore. Okay, and you want to calculate the contact time during this period. Okay, during this period, so I just show it just half of the period. Okay, so okay, and then this in this section we can treat it as the half period of a simple harmonic oscillation. Okay, and so the time is just in a problem. The time is just contact time is just equal to half of period. Okay, and we can and this is it looks like we can analyze like we can treat this motion. It's very similar to simple harmonic oscillation. So in simple harmonic oscillation, how do we calculate the period? So omega in the simple harmonic oscillation, I say there's useful information. Angular frequency times period equal to 2 pi. Okay, so if one want to calculate the period, so we can calculate the period from the angular frequency, right? So actually your period just equal to omega over 2 pi. And what is omega? Don't forget, omega is just equal to the square root of the k over m. Okay. Okay, our contact time is 1 t over 2, so that's just equal to, okay, t is this one. So t over 2, 1 over 4 pi, is this correct? Omega t equals to 2 pi, t equal to, sorry, sorry. I read it wrong, sorry, I just found this is so weird. Okay, so isn't that right? Okay, so T is equal to 2 pi over omega. Okay, what is omega? Omega is equal to K over M square root, but it's reciprocal. So it's become, it's K over M. So it become K M. Okay. So this is the right one. So T over 2 is, so it's equal to pi and square root M over K. Okay, so so a contact time is using the mass and spring constant. Okay, so this is the first problem. And second problem was the maximum compression. Okay, I think that's very easy. You just the kinetic energy, because this will have kinetic energy transform to elastic potential energy. Just use the energy conservation. 1 over 2 mv0 squared is equal to 1 over 2 kx squared. Okay, the maximum compression is, okay, so it's K M V0 square. I don't have space here. I should put more space. So, okay, we will have x squared equal to mk V0 square. And so our x maximum compression is square root of mk and V0. Okay, that's the answer. Okay, maximum compression of the spring during the contact. Okay, I think the first problem is, okay, the trick of the first problem is we can treat the system like a simple harmonic oscillation, but it's only half a period. So we can use this information calculate half period of this motion. And so, okay, and don't forget this definition. Omega is equal to, don't forget, omega is equal to square root of K over M. Yeah, be careful. Okay, and omega t equal 2 pi and t equal 2 pi over omega. Okay, okay, don't mess this up. Okay, it's very easy to memorize the wrong equation, but maybe also very easy to take a wrong note. Okay. Okay, so this is a problem. Okay, see you in next video. Bye bye. Uh-huh. Uh-huh. Ah, ha, ha, ha.